This tutorial will explore how to start performing dynamic simulation. We will focus on assigning dynamic boundary conditions, graphic output and text output. You can find the corresponding exercise files to download from the link mentioned in the description of the video. In the previous tutorial, the outdoor temperature is a static value and we now can change this to a time-changing parameter. This is defined in the Functions window. You can click on the icon at the top toolbar or from the Edit menu choose Functions. To create a new function, click on the Functions window and then click Insert after. Similarly, you can create multiple functions. A function has a reference number, in this case, T01, T02. Where T stands for temperature, you can input suffix numbers from 1 to 99. You can also link to surface heat transfer coefficient, power and other parameters as depicted in this table from the user manual. In the status bar at the bottom left, you can also read available references to input. Input the reference for first function as T01. If you click on Type, you can see several types from the list here. There are several ways to create functions in BISTRA, either via the built-in function templates, either via a climate file in EPW or TRY format or by a user-defined function file. How to define these functions will be explained in the next tutorial. For this example, we define a sine function via the built-in template. Now you can see the function graph corresponding to the input function. Then you see here the parameters. PRM1 stands for the mean value of the sine curve. This is also displayed at the left bottom toolbar when selected. The second parameter is the amplitude, the third parameter is the period and the fourth parameter is the offset to shift the phase change. For this example, say we have an indoor mean temperature of 15 degrees, with an amplitude variation of 5 degrees, over 360 minutes. We now get a sine curve fluctuating from 10 degrees to 20 degrees in 6 hours. Similarly, we create another function T02 using the sine function with parameters as shown here. Now we link these functions to interior and exterior boundary conditions. At the Colors window, for color 174, update the temperature as T01 and for color 170 update the temperature as T02. Now, if we run the calculation, the software will use the temperatures as defined by these functions. Next, we need to set the time steps for calculations. This is defined under the Calculation Parameters window. Here we use a time step of 5 minutes, which means the software calculates for every 5 minutes. Startup calculation duration is the time duration before the actual start of the calculation, which is before you actually start reporting values. The time of the startup duration depends on the thermal inertia of the model. For a lightweight facade, we typically run startup calculations 1 day prior before we record the values. So we input here as 1 day. Then, the calculation duration for this example is set to 6 hours. Click on OK to close this window. Now at the Calculate menu, click on Save Frequency. By default Save Frequency is set to off. This means we can only get the calculated results in the text output for each calculation. But we can't visualize these results at the graphic output window as the solution files are not saved. If you click on Yes, the solution file for every time step will be saved. Hence, we can visualize the results later in graphic output. If you have a complex detail it stores a lot of data, hence by default it's turned off. For this example, we turn it on by toggling it to Yes. Then you can choose with which frequency you want to store the data. If we say we store every 2 time steps, this means that we are storing data every 10 minutes. We can run the calculation by clicking on the Calculate System icon at the top toolbar. Click on Graphic Output to visualize the result. Choose Fill Temperatures to show the temperature profile for this detail. On the right top, above the legend, you can see the time for the displayed result. You can click on Next Time and Previous Time to move one time step ahead or behind. Then you can click on Go to for visualizing a particular time step. Lastly, you can click on the first time step to visualize the output of the initial time step. We can make an animation from the results of each time step using Make Movie, but a word of caution, it might take a lot of processing power for complex geometries to load results for each node for each time step. Therefore, it's better to save the images for the calculation results and make an animation video externally. To do this, click on the File menu and then choose Save Animations Images. Now you can select the location to save these image files. Upon clicking OK, you see the graphic output generating the result for each of the time steps. We also have other options similar to BISTRA to graphically visualize, such as view boundary conditions, materials, isotherms and analysis mesh. In addition to these graphic results, BISTRA can also create alphanumerical output in TXT and CSV format. The content of such a report, which will be available in the text output window and is determined by the report definition and the report frequency. Say we want to save a data file with the first column as the time, the second column as the maximum temperatures in the concrete wall, and the third and fourth columns with the indoor and outdoor temperatures. From the Edit menu, choose Report Definition. Here we insert 4 parameters by clicking on Insert After. Under Object, you can toggle with values time, date time, color, 2 colors, border BC, sun. We first define time. Then we define the color, for the exterior, it's color 170. Now under Type, you can choose what you require to analyze corresponding to that particular color. For this example, we need the temperature of the boundary condition. So we choose theta. You have many other parameters to analyze under Type as shown here. In the manual, an overview of all possible output parameters can be found. Width is the maximum number of characters for formatting the output values in the output report. Decimals are the number of digits after the decimal point, to which the output values are rounded. For the third parameter, we define the boundary temperature for interiors with color 174. Then choose Type as theta. Now for concrete with color 120, we plot the maximum temperature. Under Type, choose theta max and choose decimal as 2 digits. Under the Calculation menu, choose Report Frequency. Here a report line in the text output is written for every time step. If you say 1, the software will create a list with temperatures for every time step, which is in this example equal to 5 minutes. If you say 2, we get temperatures for every 2 time steps, which is every 10 minutes. We now click on Calculate to run the analysis. Upon completion, open Text Output. Click on the last tab, which is the report output. Here we see 4 parameters we defined in the report definition in 4 columns. The first column is time, second is the temperature for the exterior boundary, third is the temperature for the interior boundary, fourth is the maximum temperature for the concrete wall. This can then be processed in Excel if you want to create graphs. We select all, using Ctrl+A and then copy the data using Ctrl+C and paste it into an Excel spreadsheet. We now can visualize in graphical format for the derived results. Thank you for watching, see you in the next tutorial.